So my talk today is physics teaching 2.0 as opposed to 2.0. Trying to look at, guys, as physics teachers, you're really up on using technology with probeware and internet simulations, but I always wanted to know, like, are we using the technology in the best way? And so that's where the 2.Uh-Oh comes in. So I have a few examples that I wanted to go through. These first. Whoops, sorry. See, I told you I had never presented before. There we go. So lecture 1.0. Everybody knows this. I hope you know who that is. Walter Lewin, MIT physics professor. Awesome lectures. All on YouTube, whole mechanics course, whole E&M course, calculus space, great stuff. He's like a showman. He's got 3 hours of prep time before he gave his lecture. You know, he read it through 3 times, did all the board work ahead of time 3 times before he did it, like master lecturer. But it's him, and he's writing it all on the board, and he's up there, and the kids are just kind of sitting there. So how can we improve that? So that's where lecture 2.0 comes in, right? And PowerPoint. I remember when I first started teaching back in '98, and I found out I was going to have a computer in my classroom, and I was like, yes, I don't have to write on the board, I'm going to get out the PowerPoint, right? And this is what I'm going to do. We're going to put up some notes, and we're going to have some flashy transitions, and we're going to go through all these different things. And the kids are going to write them down, we're going to have a little worksheet, they're going to fill it in as we go along. I don't have to worry about handwriting it every single period, I don't have to worry about looking at my notes from year to year. It's there, it's saved, I can use it again and again and again. And then I got a whiteboard, and I was like, okay, I can take this to the next level. The kids, they can go up, they can move words around, they can drag vectors around. It's going to be really awesome. They're going to really interact with my lesson. And then now the big thing is flipping the classroom, where it's like, you know what? You got this PowerPoint that you were giving in class. Well, if you could be replaced by a computer, then you should be. And why don't we have the kids watch the videos at home of you giving your PowerPoint lecture, and then they can come into class and they can work on their homework. So, you know, it's a new way to be a 5th grader because they're piloting. One person who's doing this is Sal Khan, and he's got a whole bunch of videos, like 2,000 videos. I mean, it's crazy what this man has put up there. A very useful library, but now we're saying, okay, watch the video at home, come to class, and then I'll help you out. I'll be almost like a tutor. But, right? What are we trying to do? Is it really an improvement of what it means to teach and to learn? So we know that it's just not stuffing equations and formulas into somebody's head. And I've done it with students, and it usually just ripples out their noses and their ears 30 seconds later anyway. And you know, the great Richard Feynman, what I cannot create, I do not understand. That was written on his blackboard after he had died. And that is a real motto for me and how I run my class. And so the kids are creating the knowledge for themselves. You know, they're not getting the law of inertia from a PowerPoint. I'm trying to get them interactive and engaged in class by not talking at them, but talking with them. And this is data from a 6,000 student study of 2 different kinds of teaching methods. The one in green are the interactive engagement methods, and they have them sorted out by high school, college, university level. And the red is traditional, where it's just pretty much lecture notes, PowerPoints, and not much else going on. Students aren't discussing things with each other. And you can see clearly that the green dots are much higher on that graph than the red ones are. And it's a very famous graph. It's from Richard Hake's 6,000 student study of interactive engagement versus traditional methods. If you just Google Richard Hake, you'll get this paper, and it's great. And what this graph actually represents is pre-test score on a physics concept inventory versus the gain that they get. So it's not just a measure of where they are at the end, but actually how much they improve by. So the percent gain. You know, you came in knowing a 50%, your gain could be another 50%. And they have that worked out. And you can see clearly that none of the red dots even go above the lowest green one. So we have evidence that this works. It kind of frustrates me that there's a lot of money. Khan Academy just got, and I hate to pick on Khan Academy, it's just so easy. They just got $5 million to start their own school, a physical school, which I think is a little contradictory to what they're trying to do with whatever. So, but they're going to try to build it around this model. And I'm glad it's, somebody else's money, not our tax money that's going into this. And it just kind of really frustrates me that all this research that's been going on for years in physics education research is kind of being ignored by the media and Bill Gates and people that have a lot of money that are trying to change education and are just using, taking, old wine and putting it in new bottles and aren't really improving and doing what we know works. So I say, get the kids out and explore. So get some bowling balls, get some mallets, have them hit that bowling ball with the mallet around the lobby in front of the theater at our school. And get them to figure out the law of inertia for themselves. They don't need to get F equals ma just yet. Let them understand that if I hit something, it's going to change direction. If the bowling ball has more mass than a soccer ball, it's going to be a lot harder to get it to change its velocity. So they explore that. And yeah, I give them a sheet. I don't just say, go out and play with a bowling ball and come back and tell me Newton's 3 laws of motion. I mean, that's ridiculous. We have, and that's kind of like how do I say this? The counter argument for teaching with inquiry and interactive experiences, because they say, oh, the kids can't figure it all out on their own. And you're right, they can't figure it out on their own. But our job is to create scenarios and situations where they can explore and be guided in that exploration to get to where we want them to be. So there's a sheet for the kids, there's questions for them to answer, there's diagrams for them to make. I'm real big with diagrams and multiple representations. It's going to play again. So then they come back and we whiteboard. I've got, they're just so you get a feel for how big these are. They're about this big. These are my original ones that I got back in 2004 from a workshop that Dan Isaac ran at Buff State. I don't know if anybody here was. How's it going? So Dan's great, and so is Lowell too, by the way. I took a workshop with Lowell back in 99, 2000, when it was either at Oneonta or University of Buffalo. It was one of the two.
University of Buffalo.
Yeah. And there was another one at Oneonta. I mean, these are great, and it's a shame that some of them aren't running anymore. But so this is just one board for one of the questions about what do you have to do to get the bowling ball to stop. And they're drawing at constant speed, and then they tap it, they tap it, they tap it. And then we see in the motion diagram up top, the dots are getting closer together, but the taps are in the opposite direction. So they're starting to get a model that, oh, if I hit it once, it just doesn't stop. It needs to be continuous taps. And kids have an impulsive force model anyway. Like I found it really hard for kids to understand that what a constant push is, because they push and then they're done. And with the bowling ball and the mallet, it's kind of the same thing with the taps. And then I can kind of get at that constant push concept by saying, okay, well, what if we make the taps close together in time? And then we kind of get at that constant force thing. So the bowling ball and the mallets were really great. I hear if you could go to old bowling alleys, they'll give you bowling balls, or maybe you can get them really cheap. I got mine from the colleague that I used to teach with before he left. He wanted to build one of those giant Newton's cradles with bowling balls. And he drilled the holes in the ball. I mean, he went all out. And then when he finally got it up, it didn't work very well. Something about the spacing and the timing and stuff. So, but I was very thankful that we still have the bowling balls. So, kids really like it. And then, you're out in the hallway in the theater lobby right in front of the cafeteria, and everybody else is like, what are they doing? They're hitting bowling balls? What class is that? And the custodians give you really nasty looks because of the floor. But we don't mark up the floor, but they still don't. So, and then when we come back and we discuss, and I just blacked out a few kids' faces so nobody would be implicated. But we sit around in a group and we share out. This whiteboarding method is big with modeling instruction, which is a program that originated at Arizona State. And the whole point is that you don't front load the concepts for kids. You are giving the kids, in this case it was a qualitative lab where we were just talking about force and mass and how things change direction and change speed. But other things that you could do is have the kids actually derive Hooke's law and constant velocity formulas and conservation of energy formulas and conservation of momentum formulas on their own, just by giving them the scenarios. Instead of doing the lab as a verification, let's do it from the beginning and make it a little more inquiry-based. So these whiteboard discussions are really good. I tried, it's tough. I mean, my kids are just like everybody else's kids. They don't want to talk about, oh, I got a problem. I gotta be like, you know what, you guys gotta share out. And it's something that I constantly struggle with. So if you've been reading this stuff in my blog and you know that I'm a big component of modeling instruction, it's still, like, I have just the same problems with this as everybody else, but I think it's worth it. So I put up with some pain. It's a lot easier for me to just shut up, for them to shut up, and for me to just write the equations on the board and go through the problems and say, okay, you know, do 1 through 30 for homework, and then come back the next day and we'll go over it, and they have a quiz on Friday. It's so much easier for 1 through 30. That's kind of a lot, but they're really easy problems. But you know, you got my point. So this I find works much better, and the kids, once they understand, some of the kids are like, oh, you want me to work? You know, like, I used to just sit and memorize and get my A, and now you want me to do work, you want me to think? So it presents its own sense of struggle, but ones that are worth it. Now let's talk about Lab 1.0. You know, famous friction lab, add the masses, pull the block, get the spring scale, right? So they're going to do that, and then they're going to fill out this big data table, and hopefully they're going to come out with some relationship about kinetic and static friction, or maybe even figure out the coefficient of friction between the board and the table. So what do we do when we add technology? Oh, we replace the spring scale with a spro, and we do the same lab again. And oh, they do get a nice graph, right? They can see the point where static friction, maximum static friction, and then the average kinetic friction on the where it starts to get horizontal. So that's nice. They get really good, clean data that way. And then they fill out the same data table that they did in the first lab. And you have to kind of wonder, what are we really doing different? Are we really using the technology in the best way possible? So how can we change this? One of the things I like to do is, with that flipped classroom, right? They're like, put the video first and then have the kids do the problems in class. But my video is not about what friction is or what inertia is. The video is a tug of war, and then you ask some probing questions or ask the kids, like, what questions do you have about this video? And so right now, you know, like, what makes a good tug of war team? Why does one team outpull another? And then, oh, they start talking about force and who's going to pull harder, and then you're like, no, Newton's third law, remember? And they're like, oh yeah. And then I show them a couple other videos, and there's this one video that's great. These kids playing tug of war on a slip and slide, and then one kid cheats and he steps on the grass, and then that team wins, and then like the light bulb goes off, like, oh, it's the friction, you know? Or there's another one where some kids were kind of like moistening the bottoms of their shoes so they would stick to the gym floor more. And so now they're getting, it's friction. And we're like, okay, now we're gonna have a tug of war in class. They're like, yes, we're gonna have a tug of war. And I was like, but you're gonna have to tell me which team's gonna win. And they're like, oh no. You know, so what does affect friction? Who has the most friction? Which team's going to have the most friction? So now we do the shoe lab, but not the shoe lab like you usually do, where they're finding mu in the shoe. They don't know what mu is. We're just trying to find a relationship to see who has the most friction. And it's really great because they're like, I'm like, how do we measure friction? Well, if you pull a constant speed with the spring scale, and we had done some other activity like this before, then they know that the friction is going to be equal and opposite to the reading on the spring scale. It's going to be equal to the reading on the spring scale because it's constant velocity balanced forces. And I'm like, okay, well, all we have to do is just pull you across the floor with the spring scale. And all of a sudden, it's like, well, wait a minute, that's not going to work. My spring scale only goes with 20 newtons. I can't even get you to budge with 20 newtons standing on the ground with your shoes on. So we're like, okay, well, what if we took your shoes out and just did your shoes? And then we put weights in your shoes, and then looked at the relationship between the weight in your shoes and how much friction there was. And like, oh, and then we could extrapolate. Well, if it's, I don't know if it's a linear function, or if it's a quadratic function, or if it's a sinusoidal function, and extrapolate out to where your weight is. So we don't need to use a spring scale and drag you across the board, across the floor. We can just, you know, use the power of let's find a model for how friction works, and then we'll extrapolate out to your weight. So that's what we do. And there's nothing about coefficients or anything like that. And they do get their graph, and each group has a different slope, and we talk about, well, okay, well now, now why, I'm sorry, and we do predict a test with a tug of war rope in class, and hopefully they're wearing the shoes that they were investigating in the lab the day before, and they actually have to come up with a prediction who's going to win. And it works about 50% of the time. I'm not going to say it works every time because it doesn't, but that's just physics, and they were so engaged with that lab because they wanted to be in the tug of war. They wanted to know who was going to win, and it was such a hook for them that it was the driving force behind what we did, rather than front-loading that information about normal force, friction, and static, and kinetic beforehand, and then being like, okay, now go find the coefficients of friction for your shoe. Which is kind of cool because it's their shoe, but they've got a real good reason about why they're doing that now. And we haven't even talked about mu yet. So now we're thinking, okay, so why are we going to have a why do different people have different slopes? Well, some shoes are slipperier than others, some shoes are stickier than others. Well, why is that? Is it their dust, the type of floor, the type of shoe? Is it the weight? Is it the tread of the shoe, the size of the shoe? So now we're talking about what factors affect friction. The material, the area, the speed at which you're pulling, all these things. Now it's like, okay, now I want you to go and figure out what makes the slopes different. And then they have to come up with a designing a shoe for tug of war. You're going to make the best shoe for your tug of war team so that you can win the competition. What's your shoe going to be like? Is it going to be light? Is it going to be heavy? Is it going to have a large surface area? Is it going to have a small surface area? What's the material going to be made out of? Their surface area, it doesn't matter. And material, based on the three, and then we just did like the little Pasco sleds that have a different material underneath. The cork was better. And obviously, the more weight you put in, the more friction there's going to be. So their conclusion is they're going to want to have a shoe that has that's heavy and has a material that's rough like cork rather than smooth like plastic. And it doesn't matter what the surface area of the shoe is. And I know that's approximate for what they're doing, but so they've got that there. Again, much better than that fill in the blank, fill in the table kind of lab. And this does take more time. It takes a lot more time. And that's why somebody had mentioned that we don't give the physics Regents exam anymore. Actually, our school only gives the 5 essential Regents exams that you need to graduate. So that's global, US, English, 1 math, which will be, I guess, algebra 1 now, and then 1 science, which they teach earth science down in the middle school. So those kids will get it there, and then some of the on-level 9th graders will get earth science at the high school in 9th grade, and then that's it. And I was like, woohoo, yeah, let's do this. I made a presentation for the Board of Ed, and they were all on it. I did get some pushback from some of my colleagues because now they don't have that stick of the Regents exam to get them through every day. Well, I think that's a good thing. Another thing that we do with lab is myth busting. So, like real low key kind of myth busting, but kids have so many common misconceptions about how stuff works. So here's a myth that they had to investigate, and it was that crumple zones really only crumple up so that auto dealers and mechanics and auto body repair shops make more money in a collision. Because now, your front end is totaled, rather than it bouncing off and having a rigid car not needing any more body work. So it's a scam to make more money and not really keep you safe. So they're designing their own experiment to kind of investigate that. And they're using technology now. They got some force plates here, and they're going to decide to drop a ball, same ball, with clay, without clay. So I guess they're thinking the clay acts like the crumple zone. And we're going to compare the results that we discuss. Again, they're not deriving F delta T equals M delta V, but it's still getting at that concept. And they're still in charge, they're designing their own lab. And sometimes I give them the flip cam and ask them to make a little 5-minute Mythbuster episode where they go through their lab design. And that makes another great way to do a lab report, because they're not typing it up, they're doing video as they're running the lab. So this is what we did for our trial 1, this is what we did for our trial 2. And the myth is busted, and they get really into it. So that's another thing that we do. But again, using technology, this is physics 2.0. So how can we use technology the best way? And I mean, I think a lot of you are familiar with PhET simulations. They're awesome. They're not like click-through, pre-made, like brain pop type, narrated and shoving information down your throat kind of thing. This is totally open, sandbox type simulations. So you can do, complaining about I have to give my kids a lecture about G, M1, M2 over R squared because I can't actually manipulate big M and the other M and big G and the orbital radii. Well, they got a PhET simulation that lets you do that. So now we can use the computer instead of having it take that data for us. We can use it to do labs that we couldn't do before. That's where the real 2.0 comes in. Angry Birds. I'm the Angry Birds guy. And great physics here, and it's also lack thereof. And and the big misconception a lot of times is you're going to let your kids play Angry Birds and learn physics that way. And no, it's not like, here, go play with Angry Birds for 40 minutes and then come back and tell me, the laws of projectile motion. It doesn't work like that. And I think that's a common misconception that some people have about using games in the classroom. No, they're actually doing video analysis with this. They're actually seeing what laws of physics work and don't work in Angry Birds. And now that Angry Birds is on the web and you can do a screen recording of your computer screen, it's really easy to get data. I don't have to have kids with flip cams hovering over their iPhones or their iPads trying to get an Angry Birds video. And I had a student figure out what G was in Angry Birds world, and it turned out that if he assumed that one of the red birds, which is not in the picture, was about the size of a chicken, then G was like 3-point-something meters per second squared, which was like Mars gravity. And then he's like, well, what if it really was Earth gravity? How big would the chicken be? And then the chicken came out to be like a meter tall. And that's the red bird, which is one of the smaller ones. And then he figured out that like the white and the black bird must have been like 3 meters tall. And now they want to put these life-size Angry Bird cutouts in the hallway for like his project. So they really just sparks them, and they really get into it. This one is there's a bird that splits into 3 birds. And conservation of momentum, conserve the number. And they try to figure that out. So that's good. There's another game called Cut the Rope. We've got some pendulum action in there. The goal is to get that little candy, that red candy, into the little creature's mouth. And when you swipe across the screen, you can cut the ropes. So if you cut that bottom rope, then it's going to start to swing. Oh, can we use pendulum data to figure out what G is and cut the rope world? If you cut the other rope and it's in free fall, does the G in free fall match the G you get from the pendulum in cut the rope world? I would hope so, but maybe not. There's a little bubble in there, so if that candy gets in the bubble, then it starts to rise. Now you've got buoyancy effects going on. And then those little blue plaid things are little air, like whoopee cushions that blow out air. And then you can manipulate the candy that way while it's falling. And you can even talk about force and acceleration that way. I mean, it's a really, really cool game. And then not just games of mechanics, there's a game called Refraction, where the goal is to get that red and that blue, this is one level, the red and the blue, the yellow and the blue beam of light up to the respective targets. And there's a green target up there too, so you're gonna have to combine the red and the blue and the yellow beams to make green, and there's mirrors and lenses to bounce off, so the one on the right, that's the solution to the problem there, and there's switches and stuff like that. And there's some good physics, and there's some really bad physics in the game too, and you can ask the kids to do like a game review from a physicist's point of view, what is good and bad about the physics in this game. Like I can rotate which angle I want the refraction to come out at. You see the yellow one's got one at a 90-degree angle. I mean, it's just all wrong, but there is some stuff that's good there. Okay, homework 1.0, right? Go home, do the chapter, do the problem set, whatever it is, write a your solution, turn it in. I did this for the longest time, graded them, gave them back to the kids the next day. One of my big frustrations with this was that the kids would copy from their neighbor, and you could tell who copies from their neighbor because when 5 kids all say that 2 times 1 is 3, you know that they weren't actually working together collaboratively. but we helped each other. Well, no, you didn't, because somebody would have picked that up, you know, or the 5 that turns into an S magically on another kid's paper. And you're like, 2.S1? Like, where did that come from? You know, just crazy stuff. So how can we make this better, right? Why is it going to that one? WebAssign, right? Like, they get random numbers, and then they can't cheat off of each other. And there's a, you know, WebAssign is kind of expensive, but there's a set from University of Texas that's very inexpensive. It's, I think, under $200 for the whole school for the whole year, unlimited student accounts. And so they get that, and then like each kid gets a different question about, you know, interpreting this graph. This is just one example of a WebAssign question. And they get feedback whether they're right or wrong, so they don't have to wait for me to give them back the homework. They immediately know whether they're right or wrong. So a lot of kids, when they were making silly mistakes on their homework, you know, they get it back and be marked wrong, and they're like, oh, I don't know any physics, but it really was because they made some math, arithmetic, algebra error, and it wasn't a physics error at all. So when they got the written homework back with red marks all over it, they felt dumb. And now with WebAssign, they get the green check or the red X, and then they can figure out, oh, I got a red X, okay, I'm going to figure out where I made my mistake. Oh, I forgot to square, that was my mistake. And then they get their green check. So they're actually spending more time doing homework. And I love it. Until, I found out that a bunch of kids were paying each other to do the other kids' WebAssigns. So second year AP kids, oh, I did his class last year. I remember all that stuff. You know, $5, I'll do your website homework. Or they would, they found a way to Google, because the WebAssign questions come from the textbook. So they would figure them out on Cramster.com, and they get the text solution name, they get the equation at the end, and then all they had to do was just plug in the right numbers into the final equation, and then they get their green checks. Why were they so focused on getting the green checks? Because I was giving points for it. That was my problem. Stop grading homework. I told you he told you that I was going to speak my mind. What's homework? Think about, does your grading practice match your philosophy about learning? And if it doesn't, you need to change that. So, what does it mean for homework? Is it practice? Does that mean taking risks and making mistakes? If it is, why are you grading it? Practice shouldn't be graded. It's supposed to be practiced. If you want the kids to take a risk and make a mistake and come in and be like, you know, Mr. Noski, I really wrestled with this problem last night and I just can't get it. And I know some people grade it just for effort, not for correct answers. I also went that route too. You know, it has its pluses and minuses, but again, the kids are still, there's kids that still just copy because, well, it doesn't matter if it's right or not. I'll just write any BS thing down and make it look like I know what I'm trying to do, and I'll get my points back anyway. Even if you make it worth 10%, 5%, 1%, it's still that carrot and stick kind of thing. And they're so ingrained in that. And you know what? They still do the homework, even if it's not graded. The kids that wouldn't do the homework, they never would have done the homework anyway, whether I graded it or not. Or they would have copied it, or whatever it was. Now they have that time to play more Call of Duty if they want to. You know, that's their choice. So you think it's about coddling them, and it's not. It's really about empowering them to take charge of their own learning. So now I love Cramster.com because it gives them worked examples. You know, we teach writing. How do you get to be a good writer? You read a lot. Well, why do we expect them to walk in and, okay, so here's your lesson on Newton's third, first, and second laws. Now I want you to solve all these dynamics problems when they've never seen one done before. Or, you know, you do 1 or 2 of them, and then you expect them to do 10 more on their own. So this, you know, you get to be a better writer by being a better reader, and I think our students need to become better. Like, I learned by watching problems being done, and, you know, some people think that the kids get in like this algorithmic mode, but, you know, look at the example and then talk about the worked out example. Why is this a good method of solution? Could we have solved it a different way? Pick it apart like you would a novel. I think that really goes a long way for kids. And there's some research that says that alternating students practicing problems on their own and working, looking at already worked problems really helps. And one thing that I do sometimes with the whiteboards is I'll get one group, I'll have two different problems, and one half of the class will work on problem one, and one half of the class will work on problem two. They'll work it out, I'll go around, make sure everybody's getting there, helping any kids that get stuck, and then they switch whiteboards. And then they have to try to explain the other group's problem that's already worked out for them. So it winds up actually saving some time, because now the kids are exposed to two problems in not twice as much time, because they're not solving the second problem from scratch, but they're looking at a work example. Okay, assessment 1.0, right? Kids sit down, they take a test, and then you have to grade it, and it takes a lot of time, and then they all look at the grade anyway, and then it just gets thrown out. They don't look at any feedback that you put on it. So what are we going to do now? Put the test on the computer, right? They sit down, they take the test, and then it's instantly graded, so you don't have to grade anything at home. And some of these test programs automatically integrate with your grade book, and then you don't even have to enter the grades in the computer. It automatically gets imported in, and like, boom, it's awesome. But uh-oh, it's multiple choice, it's fill in the blank. It's lousy questions. It can't answer rich questions. So how can we give kids that immediate feedback that they want after the test is over, and save myself some time and not have to worry about asking low-level questions? So one thing I came up with is the kids are taking the test in the front of the room, and then in the back of the room, I have the answer key and these orange pens. And then when they're done, they go to the back of the room, they leave everything at their desk except for their paper. They go to the back, and then they give themselves the feedback that they need on their quiz or on their test. And I don't have to grade it as rigorously anymore, because they're leaving themselves the feedback that they need. If they want to ask me a question about something, they'll write it down, and then when I go to grade it myself, I'll have that, I'll answer their questions. So I'm actually giving them feedback that they want, because they're asking questions on the exam when they look at the answer key. And it's immediate. It's not like they get it back 3 days later and they're like, I got that problem right, but I don't even know how I did it. You know, and as a student, I've felt that many times. Like, wow, I got 100 on this test? Like, okay, maybe not 100, but, you know, I can't believe, because I couldn't do it today, you know, 3 days later. So, the best of both worlds and more, because you get to see what they think is important. You get to see what feedback they're leaving for themselves, which is really, really helpful. And you can actually help kids give themselves better feedback by giving them feedback on the feedback that they talk about meta, right? That they left for themselves. So it works out really well. And for those of you that think that some kids might cheat, they just came out with these little scanners. They're called Doxy scanners. They're USB. You plug in. I think as an educator, you can get them for maybe like $120, and just put the paper in, press the little heart button, goes right through, scans it in, saves it to the computer. If you have an Evernote account, some people that I know online are really big with Evernote. It's like this store everything, you can access it from anywhere kind of thing, and it'll automatically even like dump the file into Evernote. And now you've got a hard copy. So if there's ever an issue like, Johnny didn't really, I don't think he really knew the answer to that question, and you can go back to the original and see if Johnny kind of like slipped a pen in there. But or another thing that I've done too is with my camera on my phone. I've snapshot pictures that way too, and that works out really well. Okay, grading 1.0, right? The old grade book, write it by hand, and think about like why we did that and why we have quarters, because it just gets to be so cumbersome. This actually makes things a lot easier, right? And now let's put it online, grading 2.0. And it's all there. The kids can access their grades. I thought this was the best thing in the world. The kids could access their grades for 24 hours a day. The parents could get them 24 hours a day. I wasn't being bombarded with phone calls and emails from parents, because I could just say, check online, it's all online, all the grades are there. I could email blast out every Friday, scheduled like magic, to all my students and their parents, all of their grades and their records to date. And it was great, or at least so I thought. So, just a little sidetrack here. This is a XKCD cartoon. Gene's got one on his shirt. They're fantastic. This one is about a tornado app for your phone. It plays a loud alert when there's a tornado warning in your area. And it's got a rating of 4 out of 5 stars. What an awesome app this is to be, right? Let's see what people said about it. First person said, great UI. Many alert choices, 5 stars. Next person said, runs great, no crashes, 5 stars. Third person says, I like how you can set multiple locations, which is great, right? If you're like a traveler and you're going to be in a bunch of different states in the tornado belt, you want to have that warning set up to give you warnings for different states. How great is that? But the app did not warn me about the tornado. 1 star. Didn't really do what it was supposed to do. It didn't warn you about the tornado. And then when you average those 4 ratings together, you get 4 out of 5. Right? A 5 and a 5 and a 5 and a 1 is going to give you somewhere between 4 and 5. Well, that's the problem with averaging star ratings. And our grade books are kind of the same way. Kid gets a B+. Why does he get a B+? Well, he did all his homework. And he participates in class. And she organizes her binder really well. But he failed all the tests. So he gets a B+. There's a grade pollution involved in averaging things together. Here's another scenario. Which student would you want to pack your parachute? There's 3 students, A, B, C, and they're graphed about different times that they pack the parachute. And if they score above a 60, the parachute will be successful and it will open. And if they score below a 60, then the parachute will not open. And student A in red is good at the top with a 95, and then it fails, and then passes, and then fails, and then passes, and fails, and then passes again. 8th try, they're packing your parachute for the plane. I don't think I want to make it to pack my parachute. Student B in the blue, fail, 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 pass, 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 and getting better every time. For the 8th try, I think I want him to pack my parachute. And then student C starts off strong and then fails a lot at the end. Well, if you average all those scores together for all 3 of those kids, they all get the same grade. They all get a grade above 60, they all graduate parachute packing school, and they're going to pack your parachutes the next time they go skydiving. But I only know one of those kids that's going to really pack my parachute the way I want him to, or her to. So why are we polluting the grade and what the grade means by averaging them all together? So, same thing going back to this grade book. Grammar final, 54. What does that mean? What can this kid do? Where's this kid having trouble with writing? Is it with sentence structure? Is it with paragraph structure? Is it with thesis statements? Reading test 3. What's the difference between the kid's 33 and the other kid that got a 79? Why is that kid such a bad reader? Or why is the other kid such a good reader? Or maybe the kid really had a 70, but he brought in a box of tissues and now has a 79 on the test. Extra credit, right? What does that grade tell you? Does it tell you what you know? So I use a standards-based grading system, and this was the beauty about the online community that I'm going to talk about in a bit, is that that's where I learned about it, from a bunch of people online, and it all of a sudden made sense. Because I was struggling with grades and grading, and kids were like, well, how many more, like I had the online grading program. Well, how many more points do I need to get an A? How many more points do I need to get? What do I need to get on the next test? And it was like points. It was poison. It was horrible. Now they grade themselves based on different criteria. So, you know, instead of having a test on gravity or a test on Newton's laws, instead of a test going in the grade book, what actually goes in the grade book is a skill. When my son went to soccer camp over the summer, he got a report card at the end, and it wasn't like Jonah, B+ in soccer. It was Jonah's really good at passing, but Jonah really needs work in head moves. I'm not a sports person, so I'm sorry. So, you know, it was broken down by skill. So why don't we give the kids that information? Why don't we record that information? And this student, she started off, so the 2, the 3, and the 4 is like a rubric kind of a grade. So 2 would be, I kind of got it. 3 is like, I'm almost there. 4 is like, I know cold, and I can explain it well. And on the first thing, she was struggling with how mass and separation distance affects the effects between gravitational pulls between 2 objects. And we all know that kids have that trouble with the 1/r² relationship. They want to think that, you know, doubling the distance half the force rather than quartering the force. So she struggled with that at the beginning. And she got feedback from her quiz. And then the next time she took a quiz, oh, she took a quiz again? Yeah, she does it again. I give it to her again, or she initiates it with me again. So there's teacher-initiated reassessment, and there's student-initiated reassessment. And that's a whole other topic to talk about. But when you let kids make mistakes and learn from the mistakes and know that they can't be penalized for their old mistakes, because in the end, they're going to be better, 4, 4, 4, 3, 4, that's so much more enriching and empowering for them. Like the parachute kids. If I was actually having to give a certificate at the end that wasn't based on averages, we would give student B the parachute certificate and not student A and student C. Because we weren't holding that student B accountable for, I should say holding accountable, but we weren't penalizing him for making mistakes in the beginning. You know? Think about if what you believe really reflects in your grade book, and if not, what can we do to change that? So this is great. And it's called standards-based because you write up these standards. And whose standards? Well, it could be, it's your standards, which could be based on state standards or AP standards, but they're your standards. They don't have to be state standards. So I don't like standards-based grading. That's the standards part. Like learning-based grading, or skills-based grading, or goals-based grading, those are all really good. I think I hit the back. So then you got to boil it down to a grade somehow. I still have to give the kids a quarter grade. This comes up all the time. So how do I convert all these 3s and 4s and standards into a grade at the end of the quarter and at the end of the year? I have the goals. There's the standards broken down by 2 different ways. There's the core goals and there's the intermediate goals. So if a kid hasn't mastered anything, their grade is a 50 and not a 0. And that's a whole other discussion to have about to 0 or not to 0. I replace the 0 with a 50, and the 0 to 100 scale is not the same as the 0 to 4.0 scale. So that's another discussion for another day. I can talk assessment all day. If they master half the core skills, they've got a 60. If they master all the core skills, they've got a 70. If they master all the core skills and half of the intermediate skills, an 80. And if they master everything, it's a 90. And then to go from 90 to 100, they have to do a project. Ask them to apply something they know from my class to something outside of class. And they're working on that right now while I'm here, which is a great subplan. And also some more harder problems, more open-ended problems on the exam. So I might say a car is traveling at 5 meters per second and it steps on the brakes and comes to a stop in 2 seconds. I'm just making the numbers off the top of my head. And then that's it. I don't give them a question. And then they have to figure out what information can I calculate from all that stuff. So these open-ended or goalless problems is one of my friends likes to call them. So that's where the other 10 points comes in. 5 for the project and 5 for the more advanced problems. So now I know if you've got a 90, you've mastered all my skills and you've gone beyond and shown the application. So an A really represents what we think an A means, not I got a B on my exams and then I did extra credit, or I got a B on my exams and then I did all my homework and now I've got my A. So it really is a reflection of what the kids know. And yeah, some kids ask me, well, what if I have mastered all of the skills except for one of the core skills? Where does that put me? You know, how does that average together? Well, you didn't master all the core skills, so you're kind of hovering at a 69. And they're like, well, I know everything and I have a 69. And I'm like, yeah, but that one thing is core and it's really important. And it lights the fire under their bottom to get that skill learned, reassessed, and mastered before the quarter ends. So kids are taking more time to the feedback that they're getting, and they know that they can come back and fix their mistakes. And they're spending more time on the topic, and it's not a surprise that they're learning more this way. You can roll your own standard-based grade book. We've got the technology, right? We average the grades together with a handwritten grade book because it's easy to do. When you've got a handwritten grade book, it's hard to keep track of 20 different standards for the quarter, and the kid maybe reassesses on a whole bunch of them at the same time, and it gets to be really crazy. That's what the computer's for. Let's use the computer grade book in a new way rather than the old way. It can handle multiple pieces of information on multiple dates on multiple layers. So here's one that I did in Google Docs, and I can clearly see that standard CV1, constant velocity, the first standard, all those kids have passed. I don't have to reassess that. I don't have to spend another day getting the kids up to speed on that. I know that they've got it. But look at standard CV4, I've got some D's and some B's. I don't have any proficiency or mastery in there. And I know that maybe, since all the kids haven't mastered that, maybe I should spend some more time going over that with the kids, or giving them something to do that will help them overcome their difficulties with that. So it just leaps right out at you, as opposed to having a chapter 5 quiz, and which could be on a variety of topics and a variety of situations where kids go wrong. You really are pinpointing their problems, which is great. But there's also online stuff, and nobody's paid me to plug these two folks. Yes, they are friends of mine. I knew them before they made their grade books, but they felt as passionately about standards-based grading as I do, so much so that they said, I'm going to make a grade book, and I'm going to make it available to teachers so all teachers can grade this way and make it really easy. One's called Active Grade, and another one's called Blue Harvest. Blue Harvest is really, really special because Blue Harvest is all about feedback. So there's a way for a kid to log in and in a text box leave comments about their feedback about a particular standard. Parents can log in and leave comments, so you can have this dialogue back and forth over a particular standard learning goal. Instead of putting a grade in, like in Active Grade, you can put a grade in for each standard. In Blue Harvest, you can actually upload the actual work that the kids did. So maybe a kid did a project about Angry Birds, and that was going to satisfy these learning goals for projectile motion. You can upload that Angry Birds project in Blue Harvest, link it to the different standards, and then talk about how that plays out, which is really, really, really powerful. And that was the other beautiful thing about the standards-based grading, is that it doesn't have to be a quiz. You want to know if the kid knows X, Y, and Z concepts. I can quiz them on X, Y, and Z. I can do a lab on X, Y, and Z. They can come in and have a conversation with me about X, Y, and Z. I can overhear them helping their friends during a worksheet problem in class about X, Y, and Z. And then I can just discreetly mark it in my grade book. So different kids are getting graded on different things. It's not everybody takes this quiz and everybody takes the next quiz. You're free to pick and choose, and these grade books make it really flexible, that you can't do with a paper grade book. If you just want to write down, well, Johnny has understood Newton's law of gravity because of the conversation I had with him while he was helping Susie with a problem she was having on a worksheet that they were doing in class. You don't have to make a separate assignment that only goes to Johnny in a traditional grade book. You can just put a special assignment just for Johnny in these grade books. So it's really, really great. And then to finish off today, professional development 1.0, Physics Teacher Magazine. Great, it's great stuff. I've learned so much from that. And these conferences that we're having right now, the face-to-face interaction is great. But what's 2.0? 2.0 is a listserv. Now I can talk to people all over the United States. There's one just for New York physics teachers, which is great. And there's one just for AP physics teachers. And there's one just for people that have been to the modeling workshops. And then there's just like a general one for physics people all over the United States and all over the world. And they're great, great, great ways to get information. You ask a question, they give you feedback back. But, look what you're missing. You're going to get one snowflake if you just stick to the listserv. There's so much more out there in terms of the discussions that are happening online. So that's where blogging and Twitter comes in. So with a blog, I have this great lesson idea. I put it on my blog, and a couple hundred people have access to that instantly. They give me feedback on it. I could change it and do it differently the next day with a different set of kids that didn't have it the first day with me because of the way the schedule worked out. I can embed video in documents that I can't do in the Physics Teacher Magazine. I had a demo published in Physics Teacher Magazine I guess about a year ago now, almost a year ago. And I had this great idea, and then it took a couple months for it to get out there and then get in the magazine. And then when it got out there, somebody emailed me and said, hey, this is great. Do you have a worksheet that goes along with it? And then I emailed the guy the worksheet, and then he emailed me his improvements to the worksheet. Like, it was great. We did have that interaction, but the time delay between when I had this great idea about this demo and when it actually got out to the world was so protracted that it wasn't really useful for some people. Because I want to talk about what I'm doing now with my kids, and that's probably what you're doing now with your kids, not 3 months from now when the Physics Teacher magazine comes out with your article finally published in there. Then it's like, oh, I gotta rip it out and save it in my binder for next year. If I remember to look for that lab next year, that great lab next year. They're great for self-reflection. You know, the only person I write for is myself. And if people want to comment on that, great. And a lot of people have. I've been really thankful for that. But, you know, some of them I don't give very many comments on. And it's just for me. And it doesn't have to be anything tremendous. One of the things that I'm doing is taking a picture every day from class. And there's this, it's a separate blog that has one picture a day from class. And, you know, sometimes I get really lengthy and write a big thesis about it. And sometimes it's just like, you know, here's a cool little activity we did. And I just kind of leave it at that. And it's for me. Now, hopefully I can look back and see, oh, I have 180 days worth of all this great stuff, and I'll remember for next year. So, and to get out the reflection in my own words is so much different than what's in my head. Oh yeah, I reflected on that last lab. I reflected on that lab. That was a great lab. I know what I'm going to change next year. But then when I go to blog about it, I have to write about it. And there's more learning of my own happening in that transition from the brain to the keyboard. I have to organize my ideas. I have to make it more coherent for the people that are reading it. And it's great. I mean, English teachers will tell you that. And this kind of self-reflection is great. And now it's out there, and anybody can read it. And they can hopefully learn from some of my mistakes, and we can have this exchange back and forth. So, and I started by reading. There's a lot of young teachers that are really energetic, and they have a lot of great ideas. And they're not really into the whole list thing. You know, they're brought up on Facebook and like email, that's for like old people stuff. I don't think that that's a positive image to have of that. There's a lot of really awesome teachers on listservs with tons of experience, and I've learned so much from them. But I'm saying, don't ditch the list, broaden your horizon. There's so many blogs out there. Mine's called Action Reaction. And if you go there, I have a list of all these other physics teaching blogs. Other people that write about standards-based grading. So the other thing too, is I'm reading blogs by math teachers and social studies teachers who grade the same way. And it's great to get a different perspective from people in different subjects that I'm not getting from the physics list, that I'm not getting from the Physics Teacher magazine. It's been great. It's like the best thing I've ever done since the first modeling workshop that I went to in terms of my own growth. And then Twitter. And you're like, yeah, who really cares about what Kim Kardashian tweets about? Or what, who was it? Charlie Sheen, right? Like, who really cares about that? That's what the kids think about Twitter. For us as teachers, it's instant conversation. So everybody's online all together, and you tweet out a question. And if somebody's listening to your tweets, like they follow you, so they'll it's almost like, it's not like email, but if they follow you, then they'll get your tweet in real time, and then you can have this conversation back and forth. Or, and there's just people all over the world. There's Derek in Australia, and he's the guy that did that Slinky Drop video that went viral a few weeks ago. He also did a video about how video lectures in science aren't very effective. It's called Khan Academy and the Effectiveness of Science Videos. So that's Derek in Australia, awesome guy. There's Malone in the UK. There was a video of standing waves using kebab skewers and gummy bears. That went viral maybe about a year ago. So I got that from him in the UK. He's great. Then there's a whole bunch of people. There's like Dan Meyer, he's a math teacher. Yeah, he's a math teacher Dan, right? He's a math teacher in California, and he's awesome. And to watch his blog over the last 5 or 6 years that he's been blogging, to see his growth as a teacher, you know, he first started out saying, like, the best thing to get a lesson started is a great worksheet. And you really have to make sure that your PowerPoint slides are designed effectively and cleanly. And he's moved away from that so much now. And in terms of more about mathematical inquiry, it's really great to see that. So, and you can just listen to tweets, you don't actually have to join. or you can actually get to read it yourself. And there's things called chats. There's a science chat that happens on Tuesday nights where we all just chit-chat about a particular topic for an hour. It goes back and forth, and it's great. There's also, and I just remembered it now, and I didn't put it in here, something called the Global Physics Department. Every Wednesday night, Andy Rundquist, out in Minnesota, I think, he runs this online webinar thing where they get a guest speaker to come in and present the topic, and then you're there and you can watch the whiteboard that the person is writing on virtually from somewhere else, and you can ask questions either by text or over a microphone, and the discussion happens back and forth. It's not over Twitter, it's over Illuminate. I don't know if you may have used it before, for maybe some online classes, and it's great. Every Wednesday night, Global Physics Department. If you Google it, you'll get the information there on how to join and how to get signed up. And you can go back and listen to the old ones. They're all archived, so if you miss one, I can never make them with my 2 kids. It's like bedtime for them, and I'm doing schoolwork. So I kind of catch up on the fly afterwards, and it's really, really great. So there's all these people that are collaborating and sharing that are outside of your boundary zone, your content zone, that are really worth listening to. So I found it to be really, really amazing. I think that's my last slide. It is. And then I just wanted to show you. So this is my blog. It's called Action Reaction, and I hate that word for describing Newton's third law, but it makes a really good blog title. And my action, and I'm reacting, and other people are reacting, so I kind of like it like that. But let's see. I guess I'm just gonna over on the side, you'll see where is it? SDG blogs. So these are other blogs that other people write. Some of them write, and you might think, oh my God, I'm going to get, I don't know how many that is, 20 blogs, and you're going to get 20 more emails every day, or you're going to have to read 20 new things every day. My email box is exploding as it is. Not everybody writes every day. They write when they find something that's important to share. So you're not going to get deluged all the time. Some people write with more frequency than others. John Burke over at Quantum Progress, he does 2 posts a day. I don't know how he does it. He's got this little daughter. He's amazing. But Kelly O'Shea at Physics Blog, she posts when it's important, and there might be a 2-week span between posts, there might be a 2-month span between posts, but everything that she writes is worth reading. Shifting Phases by Mylene. She's a technical, at a 2-year college. She does electronics tech, and she's using standards-based grading, and she's got the most brilliant ideas. And if it wasn't for them, these people are not on the listserv, like Mylene isn't. Or the teaching chemistry, or I'm trying to think of something else, like Dan Meyer, Do My Dan. They're not on the listserv, and they're just other great people. So by not checking out the blogs, I think you're kind of missing out. And then there's ones that I have listed just by physics teaching. So there's some repeats. There's some people that do standards-based grading that are physics teachers, so they're here. Teach Brian Teach, oh my God, he's so awesome. I want to channel him in my class because, we're talking about misconceptions, and we got to annihilate students' misconceptions. We got to hit them head on. And Brian's like, no, wait, use that as a starting point. And then from there, they have a misconception, but it's not really a misconception. It's like a half-formed conception or an incomplete conception. And they think that for a reason. That if you don't push something, it's going to stop. It's not going to go on forever. Well, that's because they're dealing with friction. So let's not say you're wrong, but let's say you're right sometimes, and then build upon that. And then they don't feel so defeated all the time. That physics is something that I know nothing about, when it's something that they do know plenty about. They just haven't quite articulated it just yet. There's one just for people that use modeling instruction. Adventures with the lower level. She's a chemistry teacher using modeling. Which is great. Another chemistry teacher using modeling down here. Other science teachers, biology, John Doyle over at Science Teacher, greatest writer I've ever read. That's a science teacher that's online. Very poetic, doesn't do a lot of like lesson planning stuff, but really gets you thinking about what matters with kids and school. And he puts it in this elegant, like life, death, yin yang terminology style, which is just great. Just the math teaching blogs, and then I have posts. I have like a lot of posts. They're like tags. So if you wanted to see just the ones about Comcast, you can click that. Or if you wanted to see just the ones about physics education research, you can click that. So it's really handy. And it helps me, like somebody like on email that says, oh, like how do you do Newton's third law? And I'm like, oh, you know what? I have a blog post about that. I don't have to sit down and now retype this huge long email list. I'd be like, boom, here's a link to the blog post that I wrote. And it's been really effective for me to communicate because it's so much easier to send out a link to something that I've already written rather than having to retype things over and over again or finding an old email and copying and pasting it. Because you get the same questions every year. And then there's my modeling class from summer of 2004. There I am, still no hair. And where's Dan? Where's Dan? Oh, he's right there. There's Dan. Is anybody in this picture in this room? Besides Tom. So, yeah, and people all over the world are reading this. Somebody came in from India, Hungary, and Woodsville, Switzerland, and New York City, Michigan, an hour, almost 2 hours ago. So, it's great. It's been really, really great to do this. So, if you go there's where you can get a link to a whole bunch of these other blogs. And you can sign up by email for these, so every time one of these people makes a new post, you get an email about it. You can also use a tool called Google Reader, which is kind of like an email thing. It's not like an email thing, but it's a way to collect all the blogs. And you just go to Google Reader and say what blogs have been updated and just read the new posts, which has been great. And then Twitter, these are the people that follow me on Twitter. Over 1,000 people care about what I have to say. I don't know why that is, but and that's where they live. Most of them in the United States, but we got England, Asia, Africa, Australia, one in South America, Hawaii. It's just been a really amazing experience to do this. I have the Global Physics Department. Derek in Australia, it was Thursday, 9 a.m., and we were talking with him the night before, because of the time difference. So truly, truly Global Physics Department. It was great. And you don't even have to sign in. You can just I'll sign in, and you can just see. It's not about like what I have for breakfast. But some people do share those kind of things, and then you get to know people on a personal level. And they start sharing the tweets about their students in class, their kids, and then their other kids, the kids that they have at home, and sharing pictures and stuff. But I use this just for work. Like like my friends from high school, they don't really see a use for it. That's what the Facebook is for. And I try to keep my Facebook with just my friends and family. And then Twitter is more for professional use. So these are tweets that are coming in right now. Evan, I think Evan is in China. He's a science teacher there. He teaches science at an elementary school. Also doing some really great stuff. Look at that. His kids, oh yeah, China, right? Oh my God, robots. They are doing some robot stuff. That's awesome. Let's see, who else is up here? Oh, David Coffey, he's a math education professor. He's great. Fran Boudry, physics person. Great stuff. And if you want to know, I've gone through and I've figured out some great physics people to follow. So I think if you find me, there I am, yay. And I only follow 369 people. And they all don't tweet all the time either. You're not going to get this deluge of tweets of 369 tweets every second. But 1,600 people like me for some reason. And yeah, I tweet it a lot of times. It's easy when you've got the phone. When I got the smartphone, that went up exponentially. And then these are the things that I tweeted about. Hello, Rochester. And I'm originally from Long Island, and I was from Israel. But we do tweet about lab out loud, the NSTA stuff, and where's lists? So if you go to my lists, list by you, and then I have one that's called physics tweets. And there's 104 people that are related to physics. And this is showing you the last thing that each of these people have tweeted. So we share blog posts with each other, links about cool stuff. Dave is really into some NASA stuff. There's Gene right here. Oh my goodness, he tweeted about me this morning. I'm so honored. Gene does a morning verse today's agenda tweet every day. And he talks about what he's going to do in his class. And I think it's great. You know, it's only 120 characters. He doesn't go into this huge detail, but every once in a while he's like, physics of art, pinhole cameras. And I'm like, whoa, what do you do? And then I email him or I tweet him privately or publicly and be like, what do you do with pinhole cameras? And then he emails me or tweets me back a link with his lesson or a link to his website. Or he just explains it to me. And it's great stuff. So even though he's not like writing this huge blog, he just said, I'm using pinhole cameras, and that got a discussion going. So it's been really awesome. And I don't want to take up any more of your time. It's 8:45, I think, right? This is over at 9.
Anybody have any questions?
Do you guys have any questions for me? Yeah, and I feel really bad. I know the total irony of me talking to you. Trust me, I know it. But you're on my level. You know physics. You're physics teachers. We have a common experience. It's not like my kids and me, where I have this experience and they're down here, and they need to experience it so that they're up there with me. We're on the same level. So go out, get on Twitter, standards-based grading, think about what you do with your kids and why you do it, and make sure that what you believe in and what you actually do match up. And if there's that impedance mismatch, then what can you do to fix it? So, thank you so much for having me.